Welcome to today's lesson. In this tutorial, we will identify if lines are horizontal, vertical, increasing, or decreasing, and we will graph linear equations in standard form using our x and y intercepts. So we're going to be graphing our linear equations, and we're going to be focusing on standard form today. A linear equation is an equation whose graph is a line. The word line is right here in the word linear. So when we're talking about linear equations, we're talking about the graphs of lines. A linear equation includes four main types. We have horizontal lines, those go across from left to right. We have vertical lines, those go up and down. We have increasing lines from left to right. They are increasing, so they have positive slopes. And we have decreasing lines from left to right. They go downward, and they have negative slopes. The standard form for a linear equation is ax plus by equals c, where a, b, and c will be real numbers, and a and b will not both be 0. So we have our x term and our y term on the same side of the equation, and then a number or a constant on the other side of the equal sign. We can graph our linear equations in standard form by finding the x-intercepts and y-intercepts. Let's review what those are. The x-intercept, or we also call it the 0, that is where the graph crosses or touches the x-axis. An x-intercept will be an ordered pair. We will have a number for the x, and then y will be 0. Every point on the x-axis will have a y-coordinate of 0. The y-intercept, that's where the graph crosses or touches the y-axis. And for the ordered pair for the y-intercept, the x-coordinate will be 0, and then we will have some number for the y. So those are our ordered pairs that we're going to be looking for today. And if we can find the x-intercept and the y-intercept, then we can connect those two, and we have the graph of our line. Let's look at our first example. We want to graph 5x plus 2y equals 10. This is in standard form because I have my x term, and then my y term, and then my equal sign, and then my number. Let's look for the x-intercept first. Remember, the x-intercept is when y equals 0. So I have my equation 5x plus 2y is equal to 10. If I know that y is going to be 0, and I plug the 0 right in here, 2 times y would go away. This would simply be 0. So I will have 5x plus 0 is equal to 10. Or simply 5x equals 10. And that's a pretty simple equation to solve. If we divide by the 5, we have that x equals 2. And we just found the x-intercept. The x-intercept will be 2, 0. Let's plot that in our graph patch. 2, 0 would be this ordered pair right here, this point right here. We have one of our intercepts. Now let's go find our y-intercept. Again, remember that that means that x will equal 0. So if I have my equation, which is 5x plus 2y equals 10, and I plug a 0 in for x, now 5 times 0 becomes 0. And I would have plus 2y is equal to 10. Or if we remove the 0, we simply have 2y equals 10. Dividing by this coefficient, and we can find our y-intercept is y equals 5. Let's write that as an ordered pair. The x-coordinate is 0, the y-coordinate is 5. Let's plot this point on the y-axis. 1, 2, 3, 4, 5. That is 0, 5. Now that I have 2 points on my line, I can get my straight edge and connect the two to make one line, or one graph of a line right there. I'm going to put arrowheads on both sides so that I know that pattern continues forever. And that's it. We're going to find the x-intercept and plot it. We're going to find the y-intercept and plot it. And then we're going to connect those 2 points with a line. What type of line do we have? Is it horizontal, vertical, increasing, or decreasing? Well, we read it from left to right and we see that we're going downward. It has a negative slope, so this is a decreasing line. Let's look at another way we can find the x-intercept. If we know that we're plugging in a 0 for the y and that therefore this term goes away, some people literally like to just cover up that term. And then they see what's left, 5x equals 10, and they can jump right down to this equation, 5x equals 10. It's called the cover-up method. If they want to find the y-intercept, they know that they're going to cover up the x term. Now be careful if you're covering up this x term. Don't cover up this sign because this positive sign goes with the y term. And we have positive 2y equals 10. So if you're looking for an x-intercept, you can simply cover up the y term and solve. If you're looking for a y-intercept, you can cover up the x term and solve. It's called the cover-up method. Let's look at example 2. We have 4y minus x equals negative 4. Now there's something wrong with this one. This is not in standard form. We don't have the x term and then the y term. So I'm just going to move my terms around. My negative x, I'm just going to put that first. And then this 4y is going to come second, but we need to know that it's positive. So positive 4y will be the second term. And then my equal sign on my negative 4. That feels a little bit better. Let's find our x-intercept. And I'm going to use the cover-up method. If I'm looking for the x-intercept, I'm going to cover up the y term. And what am I going to see? I see negative x equals negative 4. So I'm going to write down negative x equals negative 4. I have to solve for x, so therefore I need to divide by this coefficient of negative 1. And then x will be all by itself, and I will have positive 4. So my x-intercept is 4, 0. Let's plot that. 1, 2, 3, 4. Great. If I'm looking for my y-intercept, let's cover up the x term. And what am I going to see? I see 4y equals negative 4. 4y equals negative 4. If I divide by 4, I'll have my y-intercept, y equals negative 1. So my y-coordinate, my y-intercept is 0, comma, negative 1. Let's plot that. That would be down here on the y-axis. Now that I've got 2 points on my line, I can connect those two with a nice straight line. I'll put arrowheads, and there we go. What type of line is this? We are increasing from left to right, so we have an increasing line. There's my hand. All right. Let's look at example 3. This is one of our special cases. Y equals 4. We don't even have an x term. Y equals 4 is one of our special cases. It means that the y value will always be 4. Let's name several points where the y value is 4. I have 4 ordered pairs right here, and I made the y coordinate 4. So how about 0, 4, and 1, 4, and 2, 4, and 3, 4? How about we name some other ones? How about 4, 4? How about a negative value? How about negative 1, 4? If we plotted all of these points, let's start with 0, 4, and let's go to 1, 4, and how about 2, 4, and 3, 4, and 4, 4, and negative 1, 4, what do you start to notice? Hopefully you realize that all of these points are along this nice horizontal line, and I can connect all of those points together with this horizontal line. This is one of our special cases, and I like to think of it as HOI. What does the H stand for? Horizontal. What does this O stand for? Well, it's really actually a 0 because we're going to find out that the slope is 0. And what does this y stand for? Well, that means that the equation will always be y equals some number. So I like to think of this special case, I like to think HOI. It helps me remember horizontal, the slope is 0, and it's y equals a number. Let's look at our next special case. This is x equals 1. This means the x value will always be 1. Let's list some points where the x value is always 1. How about 1, 0, and 1, 1, and 1, 2, and 1, 3? How about 1, 4? And how about 1, negative 1? Let's start to plot all of these points and see what happens. 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, and 1, negative 1. I hope that you realize that all of these points will be connected with a vertical line. A nice, straight, up and down vertical line. And we've got vertical right there. For vertical lines, I like to think of VUX. The VUX helps me to remember that the V stands for vertical, that the U, the slope, is undefined. It's an undefined slope. And that the X is our equation, X equals some number. So I've got HOI for my horizontal and VUX for my vertical. All right, I have one last example. I'd like to make this a try. It says which equation would have an x-intercept of 2, 0 and a y-intercept of 0, 3. Please circle the which equation would have those two intercepts. Pause the video and try this yourself, and then I'll come back on and make sure that we are correct. Pause now. All right, thanks for working with this one. If you had any trouble on this one, let me give you a hand. Okay, so if the x-intercept is going to be 2, 0, I'm going to cover up the y term and see if that works. I'm just going to start with answer choice A. If I cover up the y term, I get 3x equals 6. And yes, that's true, that 3 times 2 would equal 6. So this equation has an x-intercept of 2, 0. But does it have a y-intercept of 0, 3? I'm going to cover up the x term, and I'm going to see negative 2y equals 6. Well, negative 2 times 3 is not 6, so I know that answer choice A was not correct. I'll put an X through that one. But I did know that 3x had to be true, so the only other choice that had a 3x is D. So I'm going to move my sights to D and say, okay, the x-intercept, let's cover up the y term. 3x equals 6, so therefore x equals 2. Let's also cover up the x term to find the y coordinate, or the y-intercept. 2 times y equals 6, and yes, 2 times 3 does equal 6. So I do have my correct answer, and that is answer choice D. Give yourself a hand. We'll practice this in class, and I'll see you then. Bye-bye.